Swayam Prabha. Digital India. Educated India.
With the tagline, walk in with an idea, walk out with the product. Center for Innovation at IIT Madras works on the belief that innovation emerges through community interaction and freedom to learn and experiment. Let's know more about it from Professor Prabhu Rajagopal.
Hi, I am Professor Prabhu Rajagopal from the Department of Mechanical Engineering and also the co-head of the Center for Non-Destructive Evaluation or CNDE. At CNDE, our mission is to develop sensing solutions, whether it is for societal or industrial needs. And we look at sensing from a very holistic perspective. We are looking at a range of sensing solutions, whether it is in electromagnetic techniques such as X-rays, eddy currents and so on, or using acoustics or ultrasonics. So, for example, vibration based testing, ultrasonic testing, guided ultrasonics and so on. We are also looking at ways of carrying these sensors to remote locations. So, whether it is in terms of waveguide solutions or robotics, and also we look at what comes out of these sensors in terms of data, how do we manipulate that data. So, this is the kind of full spectrum view that we have in our center. So, a couple of very cutting edge solutions that have come out of our laboratory include India's first marine robot capable of performing ultrasonic inspections at a depth of 200 meters from the shore. So, a lot of marine structures need inspection more closer to the surface because corrosion is the major challenge. You can think of single buoy moorings which are deep into the sea, or you can think of port structures, or you think of bridges and dams. For example, a number of river crossings of rail and land bridges are on concrete pillars that need regular inspections. Dams that are more than 80 meters deep need inspections because any seepage can lead to catastrophic bursts, for example. So, the startup that is actually today which has inspected a number of major and minor dams in the country and that has inspected bridges for river both rail and road bridges called Planis came out of our lab, came out of one of these kinds of innovations that we did in terms of making a mobile platform for remote inspections using robotics. It's called Planis and that came out of our lab. The other cutting edge technology I can talk about is Solinas, and I am going to talk about Solinas a bit later. But the other solution is Zyma. So, Zyma for example is developing waveguide sensors. Measurement of temperature, especially at very high temperatures like above 1000 degrees centigrade, is a major challenge in many industrial settings. So, for example, whether you talk about iron and aluminum and copper, which are essential for powering the industrial revolution we are talking about, or tomorrow lithium, nickel and so on, all of these are going to require mining and mineral operations. Every one of these operations is a high temperature operation and there are very few sensors that can ensure safe operations of these plants at those very high temperatures. Thermocouples are used but they keep failing because they have junctions. We have come up with the world's first waveguide ultrasonic sensor that can be used for remote monitoring inside these kinds of environments. You can measure very high temperatures and you can also do distributed measurements, that is you can measure 100 points from a single excitation position, and it gives me great pride and joy to say that this is one of the few instances where we say we are leading the world. Very often when I go out into the industry and talk about this technology, they say, can you tell me what you are comparing against? Is there a better solution than this? And I say, yeah, there is no better solution than this. This is the best. So, that gives me a lot of pride to say that such a solution has come out of our lab. A startup called Zyma is now commercializing this solution. All the IPs that we have generated are licensed to this startup and they are taking this to the field. Now, the third solution I would like to talk about is something that is very socially relevant. So, in the context of our pipeline robots, for example, which we developed and commercialized through Planis, 7 or 8 years ago, I started looking at sewer lines. I was looking at, can we use the same tech to look at tree ingress in sewer lines, because that's a major challenge over there. Then I discovered that those robots cannot be used in this very, very tough environment. Inside the sewers, there can be all sorts of things. There can be things like garbage in, there can be chocolate wrappers, there can be sanitation pads, there can be clogging because of many years of non-cleaning and so on. Our industrial robots are not going to work here. This is where I started looking at bio-inspired robots that can power themselves like fishes and so on. And out of that quest was born a robot called Sepoy. We said this will be used for inspecting sewer lines and septic tanks. It turns out that a robot just to go inside and have a look is not of that much interest, because people are dying in these environments. And why they are dying is because in septic tanks, water tends to be stagnated. After a few years, the contents become solidified and people are going in to break down the contents so that vacuum suckers can suck these things out. So what they want is a solution that can do this heavy duty homogenization. This is what we learned from one of the NGOs we were working with. And so we started doing this. We developed a robot called HomoSep in 2019 through funds from IIT Madras's Socially Relevant Projects initiative. We also had something known as Carbon Zero Challenge, which was supporting sustainable solutions. Through these support, we created the first prototype, and immediately it was a hit. The Safai workers loved it because it was something that was addressing their need. The design was such that it was simple to use. The tech is advanced, but at the same time, it is easy to fabricate. And because we work very extensively with petrochemical industries, we came up with a novel way of homogenizing the contents here, which is similar to oil and gas sludges. We came up with a solution that is simple, easy to fabricate, easy to operate and maintain. So the Safai workers loved it. Since then, there has been no looking back. We have received a lot of CSR support. We have received support from Gale CSR, Capgemini CSR, L&T Technology Solutions, NSE Foundation, and more recently Wells Fargo. Through all of this, we have commercialized this solution, deployed it on the field. Today, I'm very proud to note that our robot HomoSep is deployed in about 20 locations across the country. Several in Tamil Nadu, 5 or 6, few in Chennai, few in Trichy, few around the Bangalore area, few around Ahmedabad, few in UP, few in Bihar, Chhattisgarh, Jharkhand, and a few in Odisha as well. So in Odisha, we have done our first sale to a government agency participating in a competitive tender bid. So this technology is now commercialized through a startup called Solinas. It is founded and headed by Divanshu Kumar, who actually was the student who developed the HomoSep as a final year project. So he has the most beautiful journey. He was also a member of CFI. He was a pre-incubatee at Nirman, and now Solinas is an incubated company at IIT Madras Incubation Cell. And they have completed the tech transfer journey. It started off as a lab project, something that was funded by CSR, filed IPs, became a pre-venture, then a fully incubated company, which is now licensing the IPs. They are also developing new IPs on their own, and now they are the primary catalyst to take this solution to the field. Other students from my lab, people like Srihari, people like Bhavesh, people like Moinak, they have all joined this startup and they are now taking it to the field. This startup won the Economic Times Best Startup Award last year in 2019. They were also featured in Shark Tank India, where they received a deal as well. And indeed, it gives me great sadness to note that we as a country are capable of developing nuclear missiles. We have intercontinental ballistic missiles. We can send satellites to moon, and we can send probes to moon. We can send probes to Mars, but we are sending young people to die in sewers and gutters. And the reason is not because we do not have the money or the technology. The reason is because we do not have the will to solve this problem. There is a community that is trapped to do this work out of compulsion. There is no technological solution that is available at a price point that they can buy and use this for, and there is no solution tailored to our very tough Indian conditions. Sometimes sewer lines and septic tanks can be in the backyard of a narrow alley. A robot that is sourced from international market is not going to go into those backyards. Our solution is developed It is an advanced technology. It comes from oil and gas industry. It is developed and tailored to our local conditions with feedback from end users at a price point that is affordable for them. And at this point, I think there should be a larger uptake from government and industry so that this solution can be scaled widely and deployed so that deaths can be avoided in this very tragic profession. And finally, what is my message to young people? There is no better time than today to cut your teeth into entrepreneurship. If you want to be an entrepreneur, if you want to solve society's problems, the nation's problems and the world's problems, do it. Doing is better than thinking about doing. That's it. That's my message to young people.